So to talk about slope, what we're going to do is we're going to consider a skier, and we're going to put him in a few different situations, and we're going to talk about what happens here. So there's two different hills here, two different mountains, and we're going to put a skier at the top of both. Just looking at the picture, who do you think is going to get to the bottom of the hill first, all other things being the same? Jason?
Right.
Okay, Jason says the guy on the right. Why?
Because it looks like the one shorter.
Okay, so it's the same height, but it's shorter, right? So it's going to be steeper. So since the hill on the right is steeper, that guy's going to get down to the bottom first. Does that make sense?
Yeah.
That's common sense, right? Okay, so how about these two? Aaron, which one? The guy on the right again, right? Now, they ran into each other. What's the difference between those two races? In the first race, they were both going which way?
Same way.
They were both going to the right, right? In this race, I flipped one of them around, and now one of them's going to the left. Did it make a difference, though, how steep the line was, if we're going to the right or to the left? No. If you go to the top of the mountain and you ski down to the right or you ski down to the left, you're still going down the mountain, right? You're still going to measure how steep it is. It doesn't matter if you're going right or left. So how about these two? Can you tell which one's steeper here? Or who's going to win? Left? What do you think, Jason?
It looks like the blue one's a little bit steeper. I don't know. Oh, no, that one really look kind of like
Does the guy on the left look blue to you? Really? Okay. Actually, if we release them, they get down to the bottom at the same. Okay, at the same time. So the steepnesses are the same here, but the hills look different. And the hills look different because they're going in different directions, right? One of the skiers is going to the right, the other one's going to the left as they go down the hill. So there's two things that we're going to consider when we're talking about slope. The first is how what?
What?
How steep it is. So the first thing the slope tells us is how steep the line is. You want to write that in your notes. The other thing, though, that it tells us, kind of like in that last example, the steepness was the same, but they were going in different directions. So the slope is also going to tell us which direction the line goes. That way, we can use the slope to distinguish between two lines that have the same steepness, but one's going to the left and one's going to the right. Does that make sense? All right, so we're going to use a formula for slope. Well, actually, we'll get to the formula in a second. So it tells us how steep it is and what direction the line goes. The steepness part, we're going to use a number to tell how steep it is. The bigger the number is, the steeper the line is. Okay, so if we had a slope like 3 and a slope of 1/2, which one's going to be steeper? The bigger the number is, the steeper it is. So if one line had a slope of 1/2 and another one had a slope of 3, which one's steeper? 3, because 3 is bigger than 1/2, right? Okay, so the steepness of the line is going to be the number. The direction, instead of using the number for the direction, anybody know what we use? We either use
like a variable like
positive or negative.
Oh.
Let's look at a few lines and we'll talk about whether it has a positive slope or a negative slope. So let me use another example here. If you read, which direction do you read? Do you read from right to left or from left to right? You read from left to right. You read in this direction, right? So we're going to do the same thing with a line. We're going to go from left to right. And if we look at this line here and we go from left to right, are we going up or are we going down?
Up and down.
Are we going up or are we going down? From left to right. From left to right, we go up. So since we're going up, we're going to call that, do you think it's positive or negative? Positive. So as we go from left to right, if we're going up, it's going to be positive. If it looks like this. And as we go from left to right, we're going which way?
Do we write that down?
Are we going up or down this time? We're going down, so the slope is going to be negative. All right, so here we were going up as we went from left to right. Here we're going down, so now it's going to be negative. How about this one?
The constant.
Is it positive or negative? It's neither. It's not positive and it's not negative. Now there's two different kinds of lines that we're going to have that are neither. We'll see both of them here in a second. We'll talk about what those slopes are in a minute. We'll get there. Don't worry. How about this one? Positive or negative? What do you think, Kevin? Negative? Everybody agree with him? I agree, because as we go from left to right, we are going down, so that's going to be a negative slope. How about this one? Yeah, that one is also neither. It's not positive nor is it negative. So let's talk real quick about this. What kind of line is this? It starts with an H. That's a horizontal line. What kind of line is this? A vertical line. So horizontal lines and vertical lines are not positive and they're not negative. And like I said, we'll get back and talk about what they are. How about that last one there? Positive or negative? That is a positive slope because as we go from left to right, we're going which way? Going up. That's a positive slope, right, Zach?
Yeah.
All right. So the formula that we're going to use, I keep trying to jump to the formula, but we're not there yet. What's the same about all four of these lines, or we'll call them hills here? What's the same about all four of these hills that the skiers are on?
Or no,
Their slopes are not the same. But what is the same? They all have negative slopes. So they're all going in the same direction. So they're all negative, but some of them are steeper than others. Okay, in fact, the steepness of all of them are different. So Alan said they're all going in the same direction, but he also was more specific and said they're all negative slopes. All right, so who's going to win this race? The guy on the right, right? So he's going to win the race because he's got the steepest slope and he's going to get down there fastest. And yes, that would be me. I would be on the bunny slopes. How about these? What's the same about all these? They all have a positive slope. Does that mean that when the skiers go, they're going to go up the hill since it's a positive slope? No. They're still going to go down. They're just going down and to the left instead of down and to the right. So they all have a positive slope. What's different about them? The steepnesses are all different again. This is just like the last one, except they're all going in the opposite direction. Okay? So what we're going to do with these lines, and these are the ones that we said we need to talk about a little bit more. Let's put some skiers on these hills. This guy right here. If we let him go and he doesn't do anything, what's going to happen? He's going to stay there. He's not going to go anywhere. Since he doesn't go anywhere, we're going to say this line has a zero slope. Okay, so this line has zero slope because the skier doesn't go anywhere. On the other hand, this guy, when we let him go, is going to what? He's going to fall off the cliff, and he's going to become what I call undefined. He is no longer defined. He fell off the cliff. So this slope right here is undefined. And I'm going to write that down. It wouldn't be a bad idea for you to make a note off to the side. This line right here has undefined slope.
I would definitely write that down. So you might be asked later on your homework assignment a question like that.
The formula we're going to use for slope, and I put formula in quotation marks because it's not really a formula that we plug something in, but it's a way for us to find the slope. The slope is going to equal something over something. And kind of like what I was talking about earlier with how we measure how steep the ski slopes are, we're going to take one number divided by another number to figure out how steep it is. Okay, to figure out how steep a slope is, what we're going to do is we're going to divide the rise, how much it goes up and down, divided by the run, which is how much it goes from left to right. So go ahead and write down this formula, and we're going to write down a couple of notes to go with it. The rise tells us how much the line goes which way, up or down. It may seem kind of silly to say that rise means going down, but it could mean that we're going down. So how do you think we distinguish between up and down? How do we tell if it's negative and positive? Should we make up positive or negative? Let's make up positive. So if we're rising but going down, so rising down, it sounds like an oxymoron, but if we're rising down, we would say that's negative. Okay, so the rise tells us how much we're going either up or down. And that's straight up or straight down. You can't go off at an angle. The run, then, is going to tell us what? Right or left. And I'm going to put the or left in parentheses, because if we can avoid it, we don't want to go to the left. We want to go to the right whenever we can. So which way is going to be positive for our run? Right is positive, left is negative, just like on the x-axis, right? Now, one other thing I want you to write down with this part here. There's a letter that we always use for slope. Does anybody know what letter represents slope? I just put it on the last slide. M. So on your notes, I want you to write in front of slope, M equals. Anytime we're writing slope or we're calculating slope, we're always going to write M equals and then whatever the slope is. All right, so M stands for slope. I know it seems kind of weird, but we use S for something else in math, so we use M for slope. Any questions about this formula? All right, then let's use the formula. If I want to find the slope of a line, there's a process that we're going to take. It's a fairly simple one. The first thing we're going to do is we're going to pick 2 points. To find the slope of a line, we always need 2 points. And I need to be careful about the points that I pick. I can't just pick any points. For example, I wouldn't want to pick this point right here. Why would this point right here be a bad choice?
Because it's not on the line.
On what line? There's a lot of lines up there. Yeah, it is on the line. It's on the green line that we want to find the slope of.
It's not on the grid axis.
It's
y-axis.
okay. It's not on the grid lines, right? So these vertical and horizontal lines we call grid lines, and we want to choose a point that is on those grid lines. So instead of choosing that point, would it be okay if I picked, say, that one right there, since it's on one of the grid lines? No, it's still not good because I'm on one of the horizontal grid lines, but I'm not on one of the vertical ones, right? So the 2 points that I picked here are what are called lattice points. I'm going to use this word a lot. You don't necessarily have to know the word, but you need to know what it means when I say it. So a lattice point is a point that crosses a vertical and a horizontal grid line. So these 2 points here that I chose, those are on lattice points. And the reason we pick lattice points is because we know the coordinates of those points. If we pick points that are not lattice points, then we don't know the coordinates. All right, so I've chosen 2 lattice points. The next thing I need to do is decide where I'm going to start. So I'm either going to start at point A or I'm going to start at point B. Now, if I'm a skier, I would probably start at point B, right? I don't want to try to ski uphill. That's not necessarily the case here. Sometimes we're going to start at the top, sometimes we're going to start at the bottom. That's not how we decide. I said this when we were doing the formula. What direction do we always want to go if we can?
Right.
We want to go to the right. So if we want to go to the right, if I want to go that way, should I start at point A or should I start at point B?
B. A.
I'm going to start at point A. If I want to go to the right, I want to start at point A. And the reason I want to go to the right is so that my run is positive. Remember, if we're going to the right for our run, that's going to be positive. So I always want to start on the left and go to the right. So starting at point A, I'm going to start calculating my slope. What was the slope formula again? It's rise over run. Okay, so the slope is rise over run. Notice that I use the letter M. So I want you just off to the side write M equals. You don't have to write rise over run again because you have that on your paper already. So you have M equals, and now we have to figure out what the rise is. So to figure out what the rise is, remember we're going to start at this point here, and we either have to go up or down. Jason, which way are we going to go?
Go up.
How far?
4.
We're going to go up 4. So basically all we have to do is count the squares here. So we go up 4, and that means our rise is what? Is that going to be positive 4 or negative 4? It's going to be positive 4 since we went up. And then once we go up 4, now we're here. We still have to get to the other point, so we're going to go which way? We're going to go to the right. How many? 2. When we go to the right, that means we're doing a run. And is that a positive run or a negative run? It's a positive run, so it's going to be positive 2. Now am I done? No, I am not done. Why am I not done? Zach? I have to simplify it, exactly. So since 2 goes into both of those numbers, I have to simplify it. And actually, I can just do 4 divided by 2, right? This fraction means 4 divided by 2. 4 divided by 2 is 2. So our answer is going to be 2. These 2 lattice points that I picked here are not the only lattice points that I could have used. I could have used this one right here. I could have used this one right here. I could have used this one right here. So there's actually 5 different lattice points that I picked there. I want to tell you something that's going to save you some work if you do it. If you always pick lattice points that are next to each other, if you pick 2 lattice points in a row, you'll never have to reduce. So like right here, we had to reduce because 2 goes into both of these. But if I had, instead of using this one and this one, if I had, say, maybe used this one and this one, so if I went from this point to this point, then I wouldn't have had to reduce. So in this problem, since I skipped over this one and went to this one, that means that I am going to have to reduce the fraction. So I'm going to do this example one more time, but I'm going to use different lattice points and show you what happens. Okay? So let's say I use these 2 lattice points right here. First of all, which one am I going to start at? Point A or point B?
Point B.
Why?
Because you gotta go. Oh,
No, not because we want to go up. Because we want to go to the right. So we're going to go to the right, which means we want to start at point B. So starting at point B, my slope is going to be rise, which means I go up how far?
2.
I go up 2, and I run how far?
1.
Run 1, I get 2 over 1. Is that the same answer I got last time?
No.
It's not?
It is.
Yeah. 2 over 1 means the same thing as 2, right? Now, I'm going to say this now. We'll talk more about it next week when we start doing equations of lines with slopes. If you have a fraction with a 1 in the denominator, usually we'll just write it as 2 and leave it as just 2. But when we're doing slope, we can leave it as 2 over 1. And that would be okay. So this right here is the same answer we got before. And doing it one more time, let's say I go the wrong way. Let's say I start on the right and I go to the left. Let's see what happens. So if I do that, my slope is going to be, well, starting here, I'm going to go which way, Aaron? Up or down? Yeah, starting here we have to go down first. So if our rise is down, then what's this going to be? What do I put on top?
-2.
So our rise is -2, and then once we do that, we're going to run, but we run to the left 1, So our run is
Negative.
-1. Did we get the same answer?
No. Yes.
Yes, except we can't write it like this. For two reasons. First of all, if we have a negative divided by a negative, it's a positive. So -2 divided by -1 is +2, and that's the same thing we got here. The other thing is, we're not allowed to write a negative on the denominator. This is something we haven't really talked about before because it hasn't come up before, but you're not allowed to have a negative on the denominator. If a fraction has a negative in it, it has to be in the numerator. Or if it has a negative on both, then you can just get rid of it. So this is the same thing as just 2 over 1. So we've done it 3 different ways, and every time we get 2 over 1 or 2 as our answer. The first thing we're going to do here is we're going to choose 2 lattice points. So I need somebody to help me out here. Somebody pick a point for me. A lattice point that's on the line. Aaron, go ahead. What are the coordinates of that top one? So since we went up 3, the y value is 3. So what are the coordinates of that? What? 3, 3? 3, 0 is over here. 0, 3. Okay, so we've got 0, 3. Now, Jason, there's 2 left. There's this one, and there's this one. Between those 2, which one should we use?
I was just gonna say the first one.
Which one? What are the coordinates?
The 0 or 1 negative. Or I don't know.
All right, so Jason is suggesting we use this one at -1, 0. Why not the other one, Jason?
This is all the way down there.
Yeah, we don't want to skip over one, right? Remember, if we skip over a lattice point, we're going to have to reduce our fraction. So if we don't skip over them, we're going to save some work. So we're going to use these 2. Should I start at this one here, or should I start at the one with the square in it?
The one with the square.
We're going to start at the one with the square in it, because we want to go from left to right. So when we go from left to right, remember, that's going to give us a run that is positive. So we're going to start by writing m equals. We always write m equals. We're going to do the rise on top. So starting at this point here, do I go up or down?
Up.
I go up. How far do I go up?
3.
Okay, so I go up 3, which means my rise is going to be what? 3. That goes on top. Run goes on the bottom. So once I go up 3, I'm going to go how far to the right? I go 1 to the right, which means that my run is 1. Remember I said it's okay if you write it as 3 over 1? It's okay if you have a 1 in the denominator? Or what else could you do? How else could you write that answer? Just 3. So 3 over 1 or 3 would be acceptable answers here. Does that make sense? All right, go ahead and try the last 2. Now, on these last 2 examples, you chose your lattice points. It's possible that you chose different lattice points that I'm going to pick here when I do the problem. If you did choose different lattice points, you should still get the same answer. So keep that in mind. If you chose different lattice points, you'll still have the same answer, at least if you did it correctly. So, I'm going to pick this one here at -3, 3, and this one here at 0, 1. Again, you may have chosen a different one. There's another lattice point right here that you could have used also. So if you use this one, you would end up with the same answer again. Okay? Now, which one of these 2, at -3, 3, or 0, 1, should we start? Where should we start? Alan says the one at -3, 3. Why? Because we want to go which way? We want to go from left to right. So we're going to start here. And even though we want to go from left to right, we have to do our rise first. So our rise is going to be which way? Down how far? So we go down 2. So we're going to say m equals, what's our rise then, since we went down 2? -2. And our run is going to be what? +3.
I got +3, -2.
Couple of things. First of all, if you pick this point and this point, your slope would be negative 4 over 6. If you get negative 4 over 6, then what do you have to do? Reduce it. If you went the other way, if you start here and you go to here, you would get 2 over negative 3. This is the right answer, but you won't get credit for it. Why not? What's wrong with this? There's a negative on the bottom. So if you do that, then all you need to do is put the negative on top and write it as negative 2 over 3. That means the same thing. Okay, so even if you go the wrong way, you get the right answer. Sorry, Chris. But you need to make sure that you write it in an acceptable way. All right, last one. Again, I'll choose the 2 lattice points. You may have chosen different ones. So I'm going to be at negative 3, negative 2, and 0, negative 2. And which one should we start at? AJ, which one should we start at?
I started at a different point.
Okay, that's okay. For these two, though, which one should we start at? Jason. Kenneth, which one should we start at? Not because we want to go up, because we want to go to the right. So if we started here, we would have to go to the left to get to this point. If we start here, we're going to go to the right. So we need our rise. What's our rise going to be? How far do we go up or down? Which way? We're going to go up 1 or down 1? We go up 1, so our rise is going to be positive 1. We're going to the right 3 times. So since we go to the right 3 times, our run is going to be positive 3.